So we go on to the next question, which is question 9. Question 9 reads, you have a certain number of coins. When you put these coins in groups of 6, 7, 8, or 9, you are left with a single coin remaining. All right, so you've got these coins and you're putting them in groups of 6. So I've got a group of, I got 6 here, I got 7 here, I got 8 here, and 9 here. We don't know how many groups there are. So it could be more than one group. They're all groups of. And you have one remaining each time. Okay, so what does this mean? Now here, if you count all the coins here, K is the smallest number of coins you have. Okay, we'll come to that just now. So here you've got 6, 6, 6. So in the end, you've got a multiple of 6, and there's one remaining. Here you got a multiple of 7, and there's one remaining. And here you got a multiple of 8, the one remaining. And here you got a multiple of 9, and you got one remaining. Okay, which means that suppose K is the smallest number of coins. The coins I have, right? I'm going to calculate K now. Okay. To say that there's one remaining, it means that K minus 1, right? I've used up all the coins, but I've got one remaining. That means K minus 1 is a multiple of 6. This is how we write K minus 1 is a multiple of 6. 6 is a factor of K minus 1, or 6 divides K minus 1. All these are synonyms. So the same thing you have with each of these. So you also have 7 divides K minus 1. You have 8 divides K minus 1. And 9 divides K minus 1. In each of those cases, you have one remaining. All right, so what does this mean now? It means that K minus 1 is a common multiple. It's a multiple of each one of them. It's what you call a common multiple. 6, 7, 8, and 9. But more than that, it's the smallest. So I can put is the smallest. Now there's a word for that. The smallest common multiple of a collection of numbers is therefore K minus 1 is equal to the LCM, that's the lowest common multiple, of 6, 7, 8, and 9. Now, I'm not going to go through how you calculate LCMs, but when you do calculate the LCMs here of all this, you get 504 for K minus 1. Now, if you want to know, it's 2 cubed times 3 squared, 9, and there is 7. 6 goes into all these things. And if you work this thing out, you get 504. 8 times 9 is 72, so it's 504. So K minus 1 is equal to that. Therefore, K is equal to 504, sorry. K is equal to 505. So that's the answer. The smallest common multiple or 6, 7, 8, 9 is 504. And when we add 1 to it, you get K. And then say it's 505. All right. Let's get on to the so the question was, N is 505. So what is the question? See, I didn't read the question. You must always read the question. I made a mistake. What is the sum of the digits of K? That's the question. So if you add the digits of 505, you will get 10. Okay. All right. So the next question is, question 10. A square is inscribed in a circle, and the line BC goes through the center of the circle. So you can see, this is what you got in the picture. If the area of the shaded region is 4 units, calculate the area of the circle. Okay, before I go on, one of the things that strikes me in this problem is you've got a line which goes to the center of a square. And one of a property of a square is the following. If you draw any line through the center, then the two pieces that are divided are exactly the same. They're identical. If you take one and put it in top of the other, it'll fit exactly. Right? It goes through the center. So it's easy enough to prove because well, actually, I don't know. I don't think I've ever tried to prove it. But anyway, if you want to say why these two pieces are exactly the same, these two are exactly the same because they are congruent. It's not difficult to see that. This is the center. So therefore, these lines are equal, those lines are equal, and you've got the included angle. So they are exactly the same. And then if you join this, so these are also congruent, so exactly the same. And if you drop another perpendicular here, I don't know why I'm using this. Instead of using the straight line one. Sorry about the clumsiness. So now these two will be also exactly the same. If I draw the perpendicular. So you got one half is exactly the same as the other half. So they have the same area. So whatever the area here is, so calculate the area of the circle. Okay, let's write down the formula for the area of the circle. Pi r squared. Okay, so let's draw the r here and see what happens. This area here is, if this area here is A, this area is also A. As I said, they are identical. And now, what is R? R is the line from the center of the circle to the boundary. So there is R. Now, if I draw two R's, do that. You see, I want to get to the side of the circle. And in a square, when you join the center, then all these triangles are isosceles triangles. And these angles are 90 degrees. And it's one of the properties of a square. If I join the two diagonals, then the diagonals are equal. They cut each other at 90 degrees. And each one is half of it. So you've got, this is your R, and this is your R. So by Pythagoras, if this is S, the area of the square is S squared. If you look at the diagram there, and S squared is equal to R squared plus R squared by Pythagoras. This is S. And that's the area of the square. They tell you the area of the shaded region is 4. So you got 2R squared. And the area of the square is 2A. And A was 4, it's given. So you got 8 is equal to 2R squared. See how you can get to the equation that you're looking for. See, once you choose your unknown, R squared, you try to get equations which you can figure out. The area of the circle, and that's what we need to calculate. So R squared is equal to 4. Therefore, the area of the circle that we are looking for, you don't have to calculate R. You needed R squared, area of circle. Area of circle, that's a question. At least now I am reading the question. Area of circle is pi times R squared, and that is 4 pi, because R squared is equal to 4. Okay, so that's the answer to that question. There you use the properties of a square. Right? If you take the center of a square and if you draw any line through it, it divides the square up into two equal parts. And more than that. If you join it to any two adjacent vertices, then you got a right-angled isosceles triangle. All the angles are 45 degrees, all sides are equal. Okay, let's just check to see whether our answer that we're looking for. Yeah, so you see right at the bottom, you got the area is 4 pi. Okay, so let's get on to the next question. So what is the sum of all three-digit palindromes? So what's a palindrome is a word, phrase, number, or sequence that reads the same forwards and backwards. So you're looking at a three-digit palindrome, it must read the same forward and backwards. So if you've got a three-digit, you can put a number A, for instance, in the front, and you have to have the same number at the end because it reads forwards and backwards. So the same thing. So you got ABA this way, ABA. So this B can be anything, A can be anything, and these are all the three-digit palindromes. It's not true that this A can be anything. This A here, it can only be from A equals 1, 2, up to 9. It's a 3-digit palindrome. You can't have 0, you see. So you must just be careful of that. So there are only 9 possibilities for A. And the B, the inside one, you can have any one of the 10 digits. And all of them will give you palindromes. Now, it's not only, the problem is not only to find all the 3-digit palindromes, but you take them and you must add all of them. So that's quite a mouthful. Okay, there could be a very large number of such palindromes. Now, what I've done here is I've actually written down all the palindromes in this picture here. So I started off with 101, went up to 909. Then I changed the middle one to 1. Right? So middle one is 1. And the flanks, the left and the right sides, are still running all the way 1 up to 9. So you got the middle one changes because there are 10 possibilities for the middle one. You got 0, 1, 2, all the way up to 9. So this gives you the full set of palindromes. Right. Now, I'm just summarizing here that what these are is 1A1, 2A2, all the way up to 9A9, where A can be 0. This is the case where A is 0. Or A could be 1. A could be 2, all the way A could be up to 9. So there are 9 values for A. Right. Now, I'm looking at this and I say, okay, let me write this thing down, but in exactly what it means. This is really 101 plus 10A. See, like here now, this is 505 plus 10. This is 909 plus 10. So, no, I'm sorry. 909 plus 30, because the middle one is the tens unit. So this is 909 plus 30 is 939. So it's 909 plus 3 tens, right? So this one here is 909 plus 3 tens. Okay, so that's what I've got here, right? The A changes. A equals 1, 2, uh, up to 9. The values of A are from 1 to 9. It's a 3-digit number, you see. So the first digit no. The A here, sorry, could be a 0. All right, so what I'm going to do is I'm going to add up all these with a fixed A. Fix A. Then after that, I'll vary the A. But I just want to see what these sums are. So when you add up these things and sum, or add, okay, so what have you got? You got 9 numbers here, running from 1 to 9. So you got 10A occurring 9 times. So that's plus 90A. Right? But in the front, you've got, let's call this S. This part is easy to calculate. It's 90 times A. But what is S? Okay. S is equal to, that's the first part, 101 plus 102. You can add all of them up to 909. Very easy to add up. The sum from 1 to 9 is 45. 1 plus 2 up to 9 is 45. Always remember that. Right? So you've got 1 plus 2 up to 49, carry 4, and the middle one is 0. So it's still 4. And then you got another 1 to 9, it's 45. So this S here is 4545 plus 90A. So what does this mean? It means that this A, I fixed it. But now, if I make A equal to 0, then I'm looking at this column here. This sum here is 45. This is 4545. This sum here is 4545. This sum here is A equals 1. So it's 4545 plus 90. I don't simplify it. Why do I keep writing 4549 plus 90? Right? Then I got 4545 plus the third one, A equals 2, is 2 times 90. Right. And like that, you go all the way up to 4545. And the last one is 9 times 90. Because the A is the middle number in each case. So the middle number is 9 in this last case. Now, how many numbers like this do you have? You have A is running from 0, 0, 1, 2, up to 9. So there are 10 values, 10 such sums, and you want to add up all these things, bearing in mind that there are 10 such sums. Now, the 4545 occurs 10 times. So it's 45. They occur in each one of these. So it's 4545 multiplied by 10, and that's easy. And then you have 90 plus 2 times 90 plus 3 times 90 and so on, all the way up to 9 times 90. Right. And in other words, this is 90 times 45. 90 is a common factor. And if you take it out, is 1 plus 2 up to 9. And that's 45. And that's 4050. 90 multiplied by. So this is 4545 450 plus 4050. And when you work this out, 450 plus 50 is 500. So you have 49500. You see, this can be quite a difficult problem if you didn't try to look at the patterns and exploit it. Like you could have added sideways, like that. And there you see, in this case, you have the ones, the numbers on the left-hand side is all the same. The middle number ranges from 0 to 9. Even here, the same kind of a thing. But then I added downwards. Okay. If you had horizontals, then you have to look at all the horizontal sums and add them. You should get to the same answer. That'll be a nice exercise. Okay, if you try to add horizontally and see what happens. $49,500. Oh, there it is. So the answer is 49,500, and that is the same answer that I got. So I'm okay. All right. So the next problem that we want to tackle is question 12. A hospital has 139 babies and 125 rooms. Or you've got far more babies than rooms. So So let's just draw these rooms. And these babies are going to be inside these rooms. And so on. But there are 125 rooms. And now these babies are going to be put into these rooms. But each room, there are 0, 1, or 2 babies. So you could have no babies in some of the rooms, or you could have 1. You could have 2, right? But you can't put more than 2. So each baby wears either a pink or a blue hat. So you got all these babies. Oh, I don't know how to draw babies. Ah, that doesn't look like a baby. It looks like certainly looks like an 8, but not a baby. All right. Pardon my non-artistic talent. Um, okay. So now you've got the babies have got either what is it? A blue, a pink, or a blue hat. Every room, the number of pink hats is even. So in the rooms, the number of pink hats are the even numbers. You can have either 0, 1, or 2 babies in each room. So P is equal to 0 or 2, right? Because the pink number of pink hats in each room, is either 0 or 2. All right. Now there are exactly 52 pink hats in total. Oh, there's not much to go around. So you have, therefore, there are. And now they say, what is the maximum number of empty rooms there could be? Okay, so it means to answer this question, you're 125 rooms, but you got 139 babies. So you want to put as many babies into a room as possible because you want to have the largest number of empty rooms. So you want the zeros. You want to have as many zeros as possible. Right. And to do that, in other words, you have to put 2 babies to each room. Right. So you've tried to fill it up to the biggest. But then 139 is a odd number. So you can go up to, but there will be one room where you have only one baby. So there are 69, right? You got 139 babies. So there are 69 rooms here, which are occupied because and then there's another one room here. 139 is 138 plus 1, and 138 divided by 2 is 69. That's where I'm getting the 69 from. So you can fill 69 rooms, right? Plus 1. So that's 70 rooms. But let's see what happens with the hats. Each baby wears either a pink or a blue hat. So you could have only 52 hats. So you can put 26. The first 26 you could have pink. All the children all the babies in the first will have pink, and the remaining 69, that makes another 43, are blue. Anyway, the pink hats and blue hats are just a distractor, because you can always put the pink hats amongst these, the babies which are there, and you know the rest of them are blue. Okay, now the question is, what is the maximum number of rooms? The answer is not straight away. You can fill 70 rooms, and then you get 125 rooms altogether. So that's the maximum number of zeros you can have, right? So you put as many zeros as possible. Therefore, you have to put as many twos as possible. And you can put as many as 69 twos and just have one room with one child or one baby in it. So that makes 70 rooms occupied. And from the 70 rooms, occupied rooms, there will be 55 empty rooms. And that's obviously the maximum, because I try to put as many children into the other rooms as possible. So the answer to this question is 55. Okay, there it is. The number of empty rooms is 55, right at the end. So this problem has really got nothing to do with pink hats and blue hats. I don't know why they give these distractors. Okay, so we go on to question 13. Yeah, question 13. Now, question 13 says there are two congruent rectangles, which means that these rectangles are identical. They've got the same length and the same breadth. So let me put that down straight away. You got, suppose the breadth is A and this is B. These are congruent, so this is A and that is B. They're both identical, so therefore they got the same length and the same breadth. Okay, each with area 25 centimeters squared. So the area of the rectangle is 25. So you got AB is 25 square centimeters. So that's the area of each rectangle. So I can, if I use the symbol A and B for the length and the breadth, then the area is A times B. Now, the problem is to find the shaded area, this area here. So how do we find the shaded area? It's a trapezium. You can see these two lines are parallel. And the area of a trapezium is half base times the sum of the parallel sides. So you could work out this parallel side and that parallel side. But the height will be from here to here. It's not clear what the height is going to be. Okay, we have that this is A. This is A also. You see, you got B, but here you got A plus B, you see. So this is not 45 degrees. So I have a problem. You can see you got a small triangle, you got a big triangle here. So this way is going to be rather complicated because it's not easy to find the height. So you have to think of some other way of doing it. It turns out that there is something, this diagram is it's telling us something. Namely that this figure is actually constructed from a rectangle and one piece has been cut out. So let's just reconstruct the original rectangle. Right? And then it now becomes quite clear how to find the area, because you call this A, this white area, B, the shaded area, and C C is the area of a triangle. See? So the you can get an equation because you got A plus B plus C. So what is B? That is the question. Question is find the shaded area. Always make sure you know what the goal is. So the question is to find B. Now you know that if you add all the three areas, A, B, and C, you're going to get the area of your rectangle. Now, what is the area of the rectangle? This part is A, so this is B minus A. It's equal to this whole thing. Well, there's A. Yeah. So you got the whole thing B minus A will be this. And this part here is B. Be careful. You might be tempted to put 45 degrees here. But there's no, these are not 45 degrees. Because you got, unless these sides are equal, then you can say the two equal numbers add up to 90. So each one is 45. But these numbers are not equal. You got A plus B is here, and you got B on this side. So this is not an isosceles triangle. Okay, but this is actually equal to, let's find these areas. You're going to get this area here is the white area A is area of a right angle triangle. So half base times height is this thing. Right. Then the shaded area, we don't know what it is. We'll hold on with that. And then the area of this part here, this is a triangle. And the area of the triangle is half base. Now the base is A plus B. Right? We are talking about this area of this triangle here. It's half base, which is A plus B, times height. So they say that the two congruent rectangles, yeah, we've got AB is 25. Okay, so what have you got here? You've got this is equal to, we're working out the area of this entire triangle. And oh yes, this is actually equal to the length times breadth. So this is half B into A plus B. Length A plus B, breadth is that. And that's the area of the rectangle. Okay, let's expand this. What do you have? You have half B squared plus half B squared here again. Okay, make it minus half AB plus B plus half AB plus half B squared. Okay, these cancel, and you land off with half into A squared plus B squared plus B. Now we haven't used the fact that AB is 25. This actually cancels out. So where did I go wrong here? So we must find the area of the shaded area. Oh, I see. Yeah. So you got that half into a squared plus b squared plus b is equal to, this is half b into a plus b. Okay, because we know the area of this entire thing. And so, and this is half b squared, half ab plus half b squared. Right, so what is b? That's what you're looking for. The half b squared, you can cancel it off here. And so b is equal to half ab minus half a squared. Okay, there's something that I seem to be missing here. Sorry, I'm not getting the answer that I'm looking for. All right, let me just double check. The a plus b plus c. Oh, I must also, oh yeah, no, a plus b plus c is this entire thing, right? And that is equal to b into a plus b. No, it's not. It's the area of this rectangle is length times breadth. So it's supposed to be like that. See? So on the right hand side, you got AB plus B squared. Right. The right hand side, you got AB plus B squared. So on the left hand side, you got the two half B squareds on this side gives you B plus B squared. Half B squared, these cancel. B plus another half B squared is equal to this. And this is equal to B into A plus B. So you have AB plus B squared. Let me just take out all this other stuff here. I seem to have made some wrong calculations here somewhere. So this is what I've got. And now, therefore, B is equal to AB. And AB is 25. Beautiful. So I've actually calculated the shaded part here. It's the same as the area of the rectangle, interestingly enough. The area of the rectangle is AB, and the area of the shaded part is also 25. Okay, so that takes me to the next one. Oh, there it is. The area is 25. Oh, I did it in some other way. It looks, yeah, maybe this might be easier. So now you have two ways of solving this problem. The one that I just did now, and there's some other way of doing it. Okay, so that's good. You've got an alternate way. Okay, let me now go to question 14. Two trains start at the same time. One train travels from town A to town B. So let's just draw this diagram. Always like to draw a diagram so that I can understand it. So you got a town A and you got a town B. And one train travels from town A to town B. And the other train travels from town B to town A. So this is what happens at the beginning. Right. Now they will cross each other somewhere along the line. If they arrive at town B and town A, respectively, 3 hours and 12 hours after they passed each other. So somewhere along the line, they passed each other. So this is the passing point. We'll call it P, is the point where they passed each other. All right. Now they say one takes 3 hours after they passed each other. So now the way I've drawn this thing here, you can see that the A speed is higher. So if you let A speed be, always like to use the symbol B for speed. B is velocity. But there are two speeds here. You got VA and you got also B. Speed would be V subscript B. Okay. So this guy travels faster because they're both in the same time. This will travel just that distance. This guy travels much more. Okay. So he continues. This is, we can put V subscript A here, and you can put V subscript B there. Right. Now they say that they arrived at town B. So it took 3 hours. Right. That means A took 3 hours to travel that distance, and the other guy is much slower. He took 12 hours. Okay. So it seems to me that A's speed is 4 times B speed. Okay. Let's just see whether that is true, because he started, he took, after they met, it takes 3 hours, but this is a shorter distance. Anyway, let's just see what we can do with this problem. Now, they both start together, 12 o'clock, and they both pass each other. They're passing each other, obviously, they're passing at the same time, 4 o'clock, whatever, which means that each of them has traveled for the same amount of time. So let's just say, let T hours be the time taken to pass each other. Okay, so now remember, this VA, it goes on towards B, and VB goes on to that. So B takes 12 hours. Right? Its speed is V. The time it takes is 12. Okay. So this is the distance he travels, VA. And VB, yeah, from here to here. And then from here to here, VB yeah, so uh, VA is traveling at the speed of V. It takes the same time. So the time it takes to travel. No, this is not travel. Sorry. Sorry. Let's just get this thing right. So what I do know is the following. VA over VB right, is traveling 4 times faster than the other guy. So this is 4. 4/1. So at the time of passing, speed is equal to distance times time. I'm sorry, distance is equal to speed times time. So what you have is the total distance AB is equal to that distance, and that distance is speed times time, right? This will travel to the speed VA, right? The time it takes there is VA times T, the meet after T hours, and the other one, it continues to travel at VB, the time it takes to travel, that distance is still the same thing. VA to reach this, and this way they meet at the same time. So this plus VB times T, that gives you these two distances, and that is equal to D, or the distance AB. So you have that T into VA plus VB is equal to AB. Now, here's something here. You see the ratio of the speeds, VA over VB, see, from the time they meet, it takes 12 hours to reach there, and this one, it takes 3 hours. So VA is faster. The speed of VA is faster. So it's going to be VA over VB is 4/1, which I have. All right. Now they say here the ratio of the speeds is P over Q. So this is also P over Q, right? The ratio of the speeds. So you will have that P is not equal to 4. Q is not equal to 1 for the time being, but it will be P is equal to 4M, so something 4 times something over 1 times something. Okay. Now they say find the sum of P and Q, but they are in the lowest terms. So this is the lowest term. You can't simplify this any further. So therefore, P plus Q is 5. I don't know, something very strange here. All right. Um, let me see what my answer is. It looks as if, so P will have to be 4 and Q will have to be 1 because this is the lowest term. So this problem, this answer to this is easier than, oh, it's 3. Okay, let me look. Oh, okay, I've got the same diagram. Um, right, it is given that VA over VB is 12. So let me just look at my answer here. I seem to have messed up somewhere. Since the trains start together, they take the same time to reach B. Also, I call this distance X, and I call that distance Y. Well, that was a good idea. That's what I missed. All right. So, so if this is X, so the X is the distance, the speed is this, so distance over VA. This is the time they take to reach P. And this guy here, he travels at VB and the distance he travels is Y. So the time he takes is distance over speed is Y over VB. So you got this equation. And then finally I got X is, yeah, so this part here, I didn't have to add the two. This X here is the distance that VB has to cover, right? Because from here now, VB has to cover the distance X, and it takes 12 hours to do that, right? So therefore, his speed is VB, and the time that it takes is 12. So speed times time is distance, so X is 12 VB. Right, that's right. Okay, likewise, the distance, now this time is VA, is the A train is moving here, and the speeds of the A train is V subscript A. The distance it travels is Y. The time it takes is 3 hours. So you got this. See, so the naming is so important, and I missed this. I didn't name this X and Y, and now everything fits in nicely because you got P over Q equal VA over VB. That's from the top there, and VA over VB from here is X over Y. VA over VB is X over Y. From here you can see what it is, and we've got X is equal to 12 VB, and Y is equal to 3 VA. Right? 12 over 3 is 4, but VB over VA, now you see it's turned around now. Your VB over VA is Q over P. Right? So you got P over Q is equal to 4 times Q over P. And then when you cross multiply, you get that. And when you're taking square roots, you get that. All are positive. So P over Q is not 4, as I said wrongly before. It's actually equal to 2. P over Q is 2, 2 over 1. So that's as low as you can get. You can't simplify that any further. So P plus Q is equal to 3. Okay, fortunately, I wrote down the answer so that now that I got stuck, I was able to correct myself. Okay. Lots of people think that the teachers are infallible. They know all the answers to all the questions. It's not true. Often we make mistakes. So this is one of those cases where we made mistakes. Okay, let's just clear all these drawings and get on to the last problem. Okay, this problem here, 3 squares, 2 of which are congruent, are shown in the figure. So these squares here, the small square is exactly the same as the square. and you got this large one is a square also. They don't give you the sizes of anything. Then you join A to this, you join this corner to that corner, and join this corner to this corner, and they meet somewhere. They don't meet along that vertical line. You can see the little dot there is not on that line. It's somewhere. And they ask us to calculate this angle. I have to tell you that it took a very long time to solve this problem. I always look for a geometric solution. They usually are the most elegant ones. And this time, I couldn't find a geometric solution, so I resorted to trigonometry. But you guys are in junior, so you don't know much about trigonometry. But nonetheless, I found a trig solution, and I've written that down here. And I was wanting to just give up there, knowing that you would not be able to understand it. Then I said, okay, maybe I'll try a solution using analytical geometry. In other words, you make this sit inside a coordinate frame. In other words, you choose an x-axis and a y-axis. And I chose it like this. So there's your x-axis, there's your y-axis, right? And I let the sides of the square be, small square be A. They are all congruent. And I let the side of the large square be B. Right? And then I said, well, the way to solve this is to see where these two lines intersect. Right? Work out the coordinates of that. And even that it became quite difficult because I needed to show that this point joined to this is perpendicular to this. Right? So I noticed that this angle here is associated with 45 degrees. You know, when you join the opposite sides of a square, you're going to get 45 degrees. All right. Anyway, that became quite a complex thing for me. And I was able to solve it using analytical geometry, quite a complicated solution. And the analytical geometry gave me a hint, because when I was solving it like that, then I realized that there were two lines which were parallel here. But to draw the two lines which are parallel needed me to draw a new square downstairs. Which is identical with this, like that. And then I saw that this line here, from here to here, is parallel to the line from here to here. Anyway, when I drew this now, I said, okay, again, it became quite complicated. And then I noticed something, that this line and these this is still A here, and they are parallel, all 90 degrees. So you got a figure which is a parallelogram. You have a figure which is a parallelogram. If I join this, this figure here is a parallelogram. And I said, okay, now that's great. It means now that all I have to do, I usually draw these construction lines in red. So I should have drawn all these things in red. Anyway, then I said, okay, now this is parallel to this, which means that the angle that I'm looking for, you see this angle that we're looking for is actually that. And it's next to this angle there. Okay, so now then it took me a long time to finally say, I need to calculate this, but these lines are parallel if I do this construction. So I need to calculate this angle here, right? And then how do I calculate that angle? Then I said, well, let me join yeah. Then I saw that this triangle here has got sides A plus B and A. And you've got this triangle. This is B and this is A. And if you join this, you have the side here is A plus B and A. So this long triangle here is congruent to this because you got the sides A plus B, and 90 degrees. So therefore, these two triangles are congruent, which means that if I these angles, this angle here is the same as this angle here. But this angle plus this empty angle is 90 degrees. So therefore, this angle here is 90 degrees. And not only that, this side here is equal to the red side that I've drawn because those two triangles are congruent. So now you have this large triangle here. The sides are equal and the angle in between is 90 degrees. So it's an isosceles triangle, which means that this is 45 degrees. But that angle there is equal to that. So that's 45 degrees. You can see even with this, it took a long time to eventually get to the answer. And that required me to perform some rather difficult calculations. I don't know, the people who set this question, I don't think they realize how difficult it was. Lots of people just lift up questions from somewhere and think it's easy because it looks easy, and they set it. But when you start working it out, it's not that easy at all. This is a kind of a problem which you can expect in the International Mathematics Olympiad, IMO. All right. Now, so the answer is 45 degrees. I just want to show you that I did the other ones. Those of you who are interested would be able to see. Here now, I did this using coordinate geometry. And you can see I didn't draw any extra figure. All I did was just join this. I needed to show that this line here is perpendicular. This line is perpendicular. And to do that, I can use coordinate geometry or analytical geometry, something which is studied in grade 11 and grade 12. So it's rather very complicated calculations. It's way beyond what they normally ask in 12. So once I did that, then, even then, you guys would not be able to understand that this is a grade 12 question, because we know that this is 90 degrees, and this quadrilateral now will be cyclic, because the opposite angles are supplementary. So if you've got a cyclic quadrilateral, then when you do grade 11 mathematics, you will have a lot of interesting things. And one of them is that in a cyclic quadrilateral, a cyclic quadrilateral is a quadrilateral where you can draw a circle which goes through all 4 points, 4 vertices. Many quadrilaterals you can't draw a circle, but in some of them you can draw a circle which goes through all the 4 vertices. And such quadrilaterals are called cyclic. They have a lot of interesting properties. And uh, just wanted to get my black line in. So if you have a cyclic quadrilateral, most of the geometry in grade 11 and 12 deals with quadrilaterals like this, where you can draw a circle. And there are lots of interesting properties, but one of them is that the opposite angles are supplementary. When you draw the opposite angles, they're 90 degrees. Now, here you have a situation like that. So that is why this is, and conversely, if the opposite angles are supplementary, then it's a cyclic quadrilateral. Right, and then if you've got a cyclic quadrilateral, one of the interesting things is when you join the diagonals, lots of angles which are equal here in a cyclic quadrilateral, and the angles which are equal are those angles. And to get that, you can from here, you go right up to that and come back. From the other end of this line, go up and come back. So you start off with one of the sides. Like you take this side here, and you go up to that vertex and come back. Let's call that a cross, and take the same thing and go to the other vertex, come back, you get this angle here. So those angles will be equal. So like that, you have, there are uh, four angles, distinct angles at the when you join the diagonals. So in this particular case here, what I noticed was this angle that we're looking for, that's the angle we're looking for. It's vertically opposite this angle here. Now this angle, if you can see, this line go up to this point and come back there. So it's a cyclic quadrilateral. Therefore, it's the same as going up to that point and coming back here. But this is a diagonal of a square. So this becomes now 45 degrees. All right. So because the diagonal of a square divides the opposites into two equal parts. So eventually you get to 45 degrees after all this calculation. All right. And then finally, there was a trigonometric solution, which, what happened to the trig solution? Oh, it seems that I wiped out the trig solution. Anyway, there was a trig solution. I can't seem to find it. Oh, I seem to have wiped it out. Okay, that's most unfortunate. It was quite a complicated solution also. Okay, I'm sorry about this. It's an extremely unfair problem. I don't expect anybody to have, in the whole country, to have solved this, but they could have guessed it because the question is, I think they give you four choices. And if you look at it, you say, oh, they're all 90 degrees and so on. So you should have a 45 degrees somewhere. And the one of the choices would have been 135 because your question was to find that this angle here, not the 45 degrees. So the answer to this question is 135. Okay, so that takes care of that, and I will stop my recording at this stage. And thank you very much for listening.